WebEx as well.
Oh, I've
To run their board meetings.
I've created my own.
Oh, good.
What is some shit?
No, I do. I do everything myself now. Geez, that would have been fun though, wouldn't it? National WebEx and all the meetings. Oh, just so you know, you're on my Saros vision.
Oh, bloody! I was talking to.
So no picking your nose.
Talking to Hardy last night.
Yeah.
You didn't return my fucking text. I said you didn't text me. You go, I saw your fucking fat head in the background when Adam had the camera on the screen yesterday. I said, I thought I'd text you. You probably texted someone else telling them they're a cunt now. Which wasn't me. No, because I said, he said, I heard you prick when you stuck your head in the door. He said, I thought it was Ivan. And he said, I realised it's your voice. John Smith there.
Let's go.
Oh, cool, mate. Enjoy.
Oh, yeah. Thank you. Hi everyone, it's Adam from Q Security here. Listen, we're just we've got quite a few late joiners today, so we're just going to wait another couple of minutes. So we'll start off at around about 10:05. Give people a bit more time to log in. Thank you. Good morning, guys. Adam from Q Security here. I hope you're having a good morning. So we'll just kick off now. We've got a few people joining a bit later on, but we'll jump into it now. Okay. So starting off with the agenda for today, I'll just run through a quick product presentation. on the Saros product, and then we'll have a physical look at the camera. Okay. Okay, so the Saros camera is it's a fairly new product that's come out of FLIR. So the product was originally conceived and designed to get around a couple of challenges that we saw in the industry, particularly surrounding things like perimeter detection. So the challenges that we faced in the industry were that perimeter detection has been traditionally far too expensive, and that is to acquire the hardware required for perimeter detection. We're also talking about the physical installation of that hardware and, of course, the monitoring of that of those perimeters as well. So typically speaking, you would be using very high-end, very expensive cameras or detectors to accomplish your requirements. And then, of course, because they're a very complex product, you would have plenty of man hours there to physically install them. And then, of course, the monitoring costs typically came via way of needing to have fairly large IT infrastructure and data throughput on a network. So that was the first challenge the camera was there to address. The second issue was that we have limited outdoor detection options. So traditionally, when we're doing outdoor detection, we really have been limited to things like PIRs, for instance, and really not a hell of a lot more other than PIRs and very high-end, very expensive thermal cameras. Obviously the approach of using visual cameras is something that has been quite popular in the past traditionally. So the problem that we have with visual cameras is that they work really well during the day, very well during the day, but they really don't deliver at night, and that is typically because of the shortcomings of visual cameras, particularly when we're looking for light sources. So the reliance on light sources for your video is really something that during the evening, if you're looking for detection, it's not a very reliable way to do things. So they'll work quite well during the day when we're looking at analytics, but at night they really just do not perform. The other approach, of course, is to use fence sensors. So this is a really, really expensive deployment, particularly if you've got large perimeters of a kilometre, 2 kilometres or more. We've obviously done studies on installations that have got 9 kilometre perimeters to protect, and you can imagine how expensive fence sensors are for that one. So they would typically go for a larger, more high-end thermal camera, and that really was the only choice there. And then, of course, we have our motion detectors that really have a very limited range. So you're typically doing very well if you're using a PIR, for instance, to get 40 metres. Otherwise, you're looking at PE beams and things like that, and then that just comes with a whole host of other issues. So those are the main challenges. There's plenty more, but we've got about 45 minutes to an hour, so I won't go through everything. But those really are the most common pain points out there. So what FLIR have done with this particular product is they've decided to set it up using their experience with perimeter detection and critical infrastructure protection. So the idea is that we've taken what we learned about radar, detection. We've taken what we learn about fixed cameras on critical infrastructure and large commercial installations, and we've also taken what we've learned about dual head camera surveillance, typically looking on the thermal side of things. And what we've done is we've rolled that into a lower end camera. So essentially the premise behind the product is a lot of the principles that we typically find in enterprise products around that critical infrastructure and that utilities type of a blueprint. So that's where the Saros camera comes in, and that was really the inception behind the product. So on that note, and to achieve that, let's just have a look at the specs of the camera really quickly on paper. So to achieve all of these things and to be able to use all of this experience and get similar results and perform similar functions on a lower budget and a lower end, the camera obviously needs to be as self-contained as possible to keep the cost down, particularly cost of deployment. So to that end, the Saros camera does have dual FLIR thermal sensors, and so they are at around about 320p or VGA each, but they are stitched together. So you actually do have about a 90-degree thermal detection range there. So although they are VGA resolution, which is for thermal, it's not too bad a resolution. Obviously, thermal, we don't have thermal sensors anywhere near the resolution of optical sensors at this point. But look, the fact that they've got two of them on there and stitched them together sort of overcomes any potential issues there. We also have a 1080p optical sensor. So right now it's 1080p, 4K is in the works, but for now it is a 1080p sensor. So that takes care of your detection and your video side. We then have our environmental components, and that includes the white LEDs. So we have white LEDs here, here, and here. So that's 3 white LEDs, and they have quite a wide spread, which allows the product to have quite a wide field of throw for the white light without having hotspots anywhere. So they're quite well positioned, and they do perform quite well. We also have our IR LEDs. So again, we have LEDs in each of these 3 windows. So these are high powered LEDs. So that's our environmental optimizations for both the thermal and the optical. We then have two-way audio and digital IOs. So what this then allows us to do is we can respond in real time via two-way audio. So we can play siren tones, or we can have a voice via audio, telling our intruder to move on. We also have digital IOs, and there is actually physical IOs on the camera, which I'll show you in a minute. So basically what that allows us to do is shoot that off to in the case of a physical IO, we can shoot that off to an alarm panel or an intrusion detection system, for example, which can then in turn report through to a monitoring station, or if it's integrated to a VMS, to the guard room there. We also have digital IOs, so we can actually use via the cloud. We can send alarms from the camera there. We also have onboard classification and analysis, which I'm going to come back to in a second. I'm just going to skip that. We have 16 gig SSD local storage on the camera. We have IP66 ruggedized housing. So I'll show you that physically in a moment, and I can tell you it is rugged. So I'm just going to jump back to our onboard classification analysis. So I'm going to actually show you how to set this up in a minute. But basically, the way that the onboard object analysis works is exactly the same as it does in the higher end thermal cameras that FLIR release. So it can tell the difference between a human form, a car, for instance, and just a standard detection. So we have those three modes available to us with this camera. Okay, so a quick recap of the features. So we've got our dual thermal sensors, we've got our 1080p optical, white light and IR illumination, low light capabilities. We have PoE, 12 volt, 24 volt, depending on your application. It is VMS agnostic, which means it is an on-VIF stream to a VMS, which works quite well. We have our physical and our digital IOs. So the physical IOs are actually packed into the base down here, and then we've got our two-way audio. So as you can see, there is a lot of functionality, and there really are a lot of bases being covered by this product. Okay. So what are the benefits that those features will deliver us? So we see the benefits as including the following, and it's not limited to it. So we obviously have our 24-hour monitoring. We have a significant reduction in false alarms. Now, the reason that it does have such a significant reduction is because all of the detection, in fact, all of the analytics for this camera are done using the thermal sensors. So, and it's all done on board. So there's no analytics for the optical sensor. It's all done through the thermal sensor. This gives us, the product also gives us visual verification. So again, you know, this is something that we're seeing a lot more of on a daily basis. So we've got a lot of people wanting to use the visual verification. We can also produce alarm clips for law enforcement. We get our real-time audio response. We can deter intruders with our white light illumination. It also integrates, because it's VMS agnostic, it also integrates with VMS, and we have really, really good return on investment for this particular product. So sorry, if you'll just excuse me for 1 second, I've just got someone trying to connect. I'm just going to quickly double back on them with the details. So if you just give me a second, please, sorry. Okay, sorry about that. All right. So where do we see the applications for this product? So we see this product as working for applications, obviously, that include perimeter detection. So that is a really, really broad brush. But essentially, you know, we're talking solar farms, power stations, you know, anything involving infrastructure, utilities, all those sorts of functions. We also have the ability to use the product in public spaces, so it works pretty well in public spaces. We've got construction, so this is one of the emerging fields that we're looking at right now. Construction. So one of the applications that we're seeing quite often now is a deployment of mobile and temporary security, including detection and video verification. So right now that's being done by combining 3 or 4 technologies together, which are quite expensive, and that's you know, that's really limiting what we can do in that space right now. So there's a couple of factors there, obviously being the cost of having an optical camera, a thermal camera, and an external white light illuminator, external IR illuminator, plus recording devices and potentially, if we're looking at alarms, some sort of intrusion inclusion. So that's typically, you look at the cost of that plus the amount of labour, and then you look at actually putting that on a pole. You then have some serious engineering to do to make sure that your weight and your distribution and power issues are covered. So with the Saros camera, you put the camera on a pole, you get power to it. And then you've got, you need some comms there, and that's really about it. So it really does give us a much better application for construction. Transportation, so we're seeing some interest on transportation through buses and rail, for instance. So this is probably a good. We've got some good applications overseas for this, where these cameras are being installed on trains, for instance. So because of the thermal detection, it actually allows the driver to see through fog. So he can see any potential issues or obstructions on the track, be they a person, a vehicle, or any other form of obstruction. And then, of course, it's compatible with many VMS systems, so not just FLIR Latitude, which of course is the VMS that we do. So it's quite VMS agnostic, and that really does widen the potential applications for the product. Okay, so solutions verticals, power facilities, utilities, chemical storage, airports, docks, embassies, and infrastructure. That's essentially where we see this product. Okay, so what I'm going to do, I'm just going to switch over now to our demonstration. So I'm just going to change my sharing, bear with me. Okay. So what you're seeing here is a thermal image from the Saros camera and the optical image side by side. So if I'm to step into the thermal image, okay. So you'll see that there's a very, very stark difference between my signature on the screen and the rest of the room. So that's one of the big advantages with thermal, is that it really allows us to sort of get a very, very stark difference between heat emitting objects, or people, vehicles, etc. Okay, so you can even see my hand left on the wall there on the door, and that'll stay there for quite some time. So they are very sensitive to heat differences and fluctuations in temperature. So these are two of the streams that we're able to pull out of the Saros. Like I said, the thermal stream is generally going to be used for detection. So you wouldn't typically monitor this as a guard, for instance. Although if you wanted to run some VMS-specific analytics using this stream, then potentially you could do that with pixel change. The changes are fairly significant. The only issue, of course, is you can tend to see a little bit more noise. So we recommend using the optical if you're going to do any VMS-based analytics, and just leave the detection to the thermal and let that be done on the camera. Okay, so I'll just enlarge. So you've got about 120, 130 degrees field of view So there is a little bit of warping, but you know, most VMSs will de-warp that for you. But this is essentially the optical view of the camera. Okay, so I'm going to give you a really quick tour of the camera physically, rather than just looking at a photo, and then we'll have a look at the programming for the camera. Okay, so here's the physical camera. So as you can see, it's fairly robust looking unit. It's tri-axis as well, so up, down, and turn. It's quite it's a nice strong enclosure there. So that's Vanderproof polycarbonate, of course, at the front there. So these are your LED ports down the bottom there. We also have our thermal LED, infrared LEDs and white LEDs in here, and then our optical and our dual thermal sensors here. So I'll give you a quick look at the white light, so I can control the white light. So what I'm going to do is I'm going to jump into the web server for the camera. So all the programming for the camera is actually done via the web server, and that is, again, that's a design decision. So the idea is that this particular camera is as standalone as possible. All right, so here we have the web server. So we'll jump through the menus. So we've got our video tag here, and this is basically where we control the streams. So right now I'm sending two streams. I'm sending the visible stream, and I'm sending visible one. So I can set that as a main or high profile. Set the resolution, rate control. I can control the bit rate, iframe intervals, which is quite handy for a camera like this, obviously. So that's my first stream. My second stream, I can then set that independently. So I might have a live stream and a recording stream, for instance. Live stream might be lower resolution, lower frame rate, while recording at full frame rate. And then I have my thermal stream. So the thermal stream is what we're seeing coming into the latitude control center, which is this one here. So there's a couple of different modes for the thermal stream. So we have thermal only. We have what we call unified 1. So what that does is that combines the visual and the thermal stream and resizes them so that they are 50-50 on the screen there. So I'll bring that up here, and you can see that a little bit better. And then we have the unified 2. So unified 2 basically sizes the streams as their real resolution. So you'll see that the thermal stream will appear in a second to be significantly smaller. So again, I'll jump over to Control Center there, and you can see that the thermal stream is now being represented at its true resolution. So nice little features to have there. Should you want to use them, I typically just use the thermal by itself on the thermal stream. But obviously, that's going to, if you're looking at a VMS, then channel licenses are probably going to be the driver for that one. Okay. So in our visible spectrum, we have all of the usual settings: your brightness, contrast, hue, all that sort of stuff, which is pretty stock standard. We then have our our focus. So it is a very focal camera, and we can focus it either near, far, or auto. So that's going to depend on where the field of view needs to be, what is the object of interest, how far from the camera is that object of interest, and how much of the field of view we want to capture in focused and clear video. And then we have our night mode, so I can switch that to color or black and white. So that really depends on what sort of illumination we have. So if we do have ambient illumination, you might find that keeping it on color for night mode works better for the visual sensor. Otherwise, you can switch it to black and white if you only have infrared illumination. And then, of course, our video format, which is pretty standard. On the thermal side, so we have our different settings for thermal. We've got the standard rainbow and lava, if we like. So the rainbow does tend to give you a little bit more definition, I suppose you might say. So if I turn on the image details, you can see I get a little bit more details of the room showing up there. So if I switch that back to, I think for me, I prefer the black and white. It just brings up the heat signatures better, and you don't have quite as many mid-range artifacts on the screen. So it needs to be quite bright for it to show up. Okay, so we can switch some of the pages through the video thermal or unified. You can't on this one, but this does exist on each page, but it just doesn't work on all of them. This is right now. This is indicating what I've selected back here at the video stage. All right, we've got our IOs. So we've got local or external IOs, and we've got our input or our output. So local being physically on the camera, and external will either be virtual inputs going to another system or to a monitoring sensor, etc. Okay, so we can also switch our input pin on or off. So this can be useful as a somewhat of a quasi sort of an arming type of a function. So I'll come back to that in a second. Okay, and then of course we have our idle state. So we can arm or disarm based on our whether the input needs to be a normally open input or a normally closed type of an input. We have our illumination. So what I'm going to do here, this is one of the pages I can switch manually. So what I'm going to do now is I'm quickly going to grab the camera. All right, and I'll see if I can get that switched to black and white. Probably helps to turn the infrared to auto. There we go. Okay, so that's the auto switching on the infrared there. Now, one thing that I want to point out here, let me just get that to switch back to infrared. So the camera is analyzing the environment to switch to infrared. However, we have some illuminators on the camera, which I will just show you now really quickly. Okay. So what I'm going to do is I'm quickly going to, so we've got the IR LEDs on there right now. What I'm going to do is I'm actually going to go over and switch on the visible LEDs. Okay, so you can see they're quite bright. But one of the really important points to make for this particular function is that typically when we look at infrared on cameras, there's a couple of things that are happening. So you are switching from an infrared environment, or switching to an infrared environment when the light goes, when you get low light. Now that's useful for the vast majority of cameras, and that'll work quite well most of the time. One of the issues that you do face, however, is the time taken to switch back to color when the environment turns to a brighter light. So, for instance, with most cameras, what you will actually see is you will see a change over a period of up to a couple of seconds. With the Saros camera, because it's all built in to the same camera, what's actually happening is when I go to infrared, so the camera is analyzing the scene and then switching. Okay. However, when the visible light comes on, and this can be triggered by a detection on the thermal side of the camera, when I click the on button there, so that's almost instant, changing back to color. And the reason it is so quick is because I'll just turn those off. The reason it is so quick is because it's not, the camera's not actually evaluating the environment there. It's just simply detecting an internal command in the software. So as soon as it sees a command saying turn on the white light, it also receives a command saying go back to color. Okay. So that is a really, really good feature for the camera, and it generally, you can cut a couple of seconds off a switch back to color from infrared and from black and white, which can at times be the difference between capturing, what color hat the intruder was wearing, what color jeans they were wearing, what color their jacket was, and seeing some of the details on there as well. So that's quite a good feature, that one. Okay, so we're going to switch over to the video analytics now. So this is probably one of my favorite parts of this camera, and I really do think it's probably one of the best features. All right. Okay, so we've got different regions that we can add in the thermal scene here. So what I can do is I can add a couple of different forms of detection. I can add a cross-line detection. So I click on my cross-line and I just draw it on the screen there. And then that comes up with a direction. So that right now is set to detect on any direction, and I can then trigger alarms or whatever I want to trigger based on that. Okay. So what I then do is I click on the tripwire there as an area, and then I set my parameters. So I might decide I don't want to be going both directions. I only want to be going left, for instance. Once I save that, you'll see it update. So that's now coming from the left to the right, and vice versa. I can change that the other direction as well. One of the really nice features here is that I then classify either via human, vehicle, or detection. So if I classify this particular analytic that I'm looking for humans only, then anything else that crosses that line will not trip, or will not trip the alarm. Just humans will trip it. Now, there's a little bit of scene analysis that needs to be done, of course, but that's as it is with all thermal. What I then have the ability to do is do region-based analytics. So I can just fill in a box here. And now what I'm looking for is movement within this particular area. And I can do the same things there. So I can look for humans, vehicles, or just detection. So the detection will pick up any heat signature that is of enough pixel density to be detected. Okay. What I can also do is I can mask certain areas. So I may want this whole area set for detection, but I might decide that this particular area here I want to mask off, and that may be some sort of a heat source that's continually moving. So you might find I don't know, in the middle of summer, for instance, you might find trees that have been warmed by the sun over the course of the day take a fair while to dissipate their heat. So you may find that you get false alarms from that sort of environment. Those are the sorts of things that we're looking at with this particular feature. So we can just block those out by masking them. The other thing that we then do is we have our arming and disarming. So again, this is like an alarm panel in a sense. So we can arm or disarm the analytics, and it's literally just a button here. So I arm or disarm. Okay. All right. So we will move on quickly to some of the rules that you can use for this product. Okay. All right. So if we come into our alarm section, so these are basically the rules that we have for the product. So we have the visible LED turning on any sort of motion within the detection area. We also have an output on motion, and we can arm and disarm the analytics with an input. So arming and disarming the analytics with an input, again, that's a really good feature for integrating with an intrusion panel of some sort. So when you arm an area, for instance, it's kind of like a key switch arm for those of you that are familiar with intrusion detection. So a key switch arm is basically an input on an alarm that arms or disarms the system. So this works in exactly the same fashion. So we can have the arming or disarming of a intrusion alarm panel, sending a output to the camera, which then will interpret that and arm or disarm the analytics based on the state of that input. So it integrates quite well there. But we can of course do it independently as well if we like. Okay. So that's fairly simple. All right. So the last thing I'm going to go through with you guys now is the physicalities of the camera. So I'm going to pull the camera apart and show you what's inside. So there's the way that this camera has been designed, and there's quite a lot of forethought going into the camera. So it does come in two separate packages. So this package here, this is actually your installation product. So this is the base of the camera. So the idea being that this will be passed to your installation technician. They can go and cable up the camera. And then, of course, we have the camera and accessories. So this is the top part of the camera. So this is this part of the camera here. So this can be sent out to site separately, meaning that the base can go out there, be installed, cabled up, ready to go, and there can be some commissioning or pre-programming done on the camera itself, back of the office. Okay, so I'm just going to pull the camera apart so you can actually physically see what's in there. Okay, so that's the base of the camera, and it's a bit difficult to see at this resolution, sorry, but essentially what you've got inside here, these are all your terminals. So you've got your inputs and your outputs, your audio ins and outs as well, and your voltage in and out if you are using a separate power supply. You've then got an RJ45 connector here, which allows us to pre-terminate the base on site. So that's all ready for your commissioning technicians when they arrive at site. And then you've got a little port here. This actually integrates to the camera. So this is effectively a pass-through port for all of these ports here. You've then got the physical camera. So on the physical camera, just at the bottom here, that's the integration port there, just a set of pins essentially. And you've also got a RJ45 here. So this is for pre-commissioning. So this RJ45 essentially gets passed through this connector here when you put it into the base. So, and the way you do that is we just take our base, we just throw the camera on the top, turn that, and we're installed. So as you can see, it's around about a 10-second install with some security screws on the sides there as well to fix the unit. Okay, so really quick and easy install process with this one. Not really a lot to it. Some of the nice little features. So we've got some cable guides here that allows you to sort of neatly tuck the cable in there. And we also have our glands here. So we've removed this gland here just to show you the hole, but it is exactly the same there. But one of the nice things about this is that a pre-terminated Cat5 or Cat6 or whatever you're using will actually fit through there. So that works really well. Okay. All right. So getting back to we just got the last two slides of the presentation here. So this is basically giving you a little bit of an understanding of how this looks and where this works. So this is basically an application we've got, and there is a video which I'll send a link for you all as well. So essentially, we have a trip line here, and so anyone stepping onto the boat will trip that trip line and then turn on the white illuminators, which works pretty well. Okay, so you've got that simultaneous thermal and optical feed, which really does help with verification of alarms. So you've got your alarm detection, and then you have your visual verification straight away. Okay, and the last point for me to go through is that the Saros camera is now available on the Raven tool. So for those of you that don't know about the Raven tool, essentially what it is a tool that allows you to optimize your designs for any of the FLIR thermal cameras. So it uses Google Earth for a KLM file, and it allows you to plot out your detection ranges. So as you can see here, we've got a couple of wide-angled thermal cameras here. So essentially what this allows you to do is select your field of view. It will then give you visual verification of the detection range. So the Saros camera is now available on that tool. It's now integrated. So we can help you with some designs for your applications. So that's really it from me. Now, unfortunately, we were hoping to have Sam from FLIR on the call, but he's having some issues. He's over in Singapore at the moment, so he can't get onto the webinar, unfortunately. So what I'm going to do in lieu of that is, if you do have any questions, please shoot them through to the email address that you got the invitation from, which was promotions@qsecuritysystems.com.au, and we'll be able to answer those questions for you. So I'd like to thank you all for your time. We really appreciate you taking the time out of your day to come and have a look at our products and spend a little bit of time with us. So we are very, very keen to get this product out to market. It's a fantastic product. I don't discuss pricing on these webinars simply because there are some integrators here that do have their end users in the room with them so that they can have a look at the product. So it is obviously commercially sensitive. But if you are after pricing, just contact your local Q branch and they'll be able to help you out with that. But please do feel free to shoot any questions through to that promotions email, and I will ensure that that they are responded to ASAP. This webinar is also being recorded, so I will be posting links to the webinar if you would like to see it again. So unless anyone's got any questions, that just about wraps it up for me. I hope you guys have really enjoyed the webinar and you got something out of it, and I look forward to seeing you again. Thanks. Not a problem here. Not a problem. Thanks for that. Thanks for being there. All right, guys. Well, have a great day, and I hope to speak to you very soon. Thanks very much. Hello? Hello? Anyone there? Hello? Anyone there? Hello? Hello? Anyone there? Hi, can anyone hear me? Hello? Hello? Can anyone hear me?
Hello? Hello? Anyone there? Hello?